Today let's talk about function rules. Okay, function rules. Remember that every function is going to have an input, output, and a rule. The function's rule is, what do we do with the input? Okay, so if our function were y equals x plus 2, that means our input is x, our output is y, and our rule is add 2 to the input. That's the rule. Okay, a function's rule tells us, what should I do with the input? So here the rule would be add 2 to whatever number I get, x plus 2. Now, this is an easy example, but some functions are going to be really complicated, and you have to figure out, you have to think about how to get your output, or sometimes you might be given an input and you might be given an output, and you have to figure out what is the rule. For example, if this is our input-output table, if you see our input is 1 and our output is 10, and you need to figure out what is the rule. You could figure out the rule by observing what happens between the input and the output. Okay? Now, if all you saw were 1 and 10, that would be impossible to figure out the rule. Because this could be any number of things, right? You could add 9, you could multiply by 10, you could multiply by 20 and then subtract 10, etc., etc. So in order to figure out a rule, we need another set of input-output pairs. So if you saw 1 and 10 and 2 and 20, now it should be pretty easy to figure out. For every input we get, it looks like we multiply by 10, right? So if this is your hypothesis, okay, if this is your hypothesis that we need to multiply the input by 10, how can we write out the rule for this function? Well, remember, in general, a function's form is going to look like y equals something with x. Right? Here's our input, here's our output. So for this sample problem, all we need to do is what? Our y is going to be x times 10. Boom. This would be our function, and then the rule would be multiply x with 10. This would be our rule right there. Now, a hypothesis is an educated guess about what will happen. Okay? Typically, it's a word that you'll see in science class. Hypothesis is going to be something you guess that will happen in an experiment. But for math, we can do that too. Okay, let's look at more tables and make more hypotheses. All right, so this time, what if we saw this now? Okay, I'm gonna make another set of XY pairs. So here's another table. What if you saw this now? 8, 5, 7, 4, and then 5, 2. X is our inputs, Y is our outputs. What's happening to get from 8 to 5 7 to 4, 5 to 2. Well, it looks like our rule would be what? For every x we have, we simply need to subtract 3. Right? So if this is our rule, our function would simply be y equals x minus 3. Okay, no matter what input you give, x can be, an infinite number of numbers. No matter what the x is, you're simply going to subtract 3, and that will be your output. Okay? Now let's get a little bit more complex. What about x and y? What about if you give our function 4, the function will turn the 4 into a 16. You give it 7.5, it'll turn into 30. You give it 9, you get 36. Input, output. Our output is going to take the input and do what in this case? Hopefully you can see it. Multiply by 4. Okay, this is our function. Our rule is multiply by 4. Now, what if instead of inputs and outputs now, what if you're given the outputs, okay, say the output is 10, 15, 20, and 25. What if you're given the outputs and then the rule? Could you figure out the inputs then? Well, yeah. All you need to do is just plug in the y values. So first of all, if you look at this, this function simply says whatever our input is, multiply it by 5. Okay, so you have two ways of finding the inputs for this particular problem. The first way is substitute the y's. Substitute the y's and then solve for x. Okay? The second way, they're very similar actually. The second way is simply do the inverse. Do inverse operations. Okay, so either way works. Let me give you a sample of method 1. Okay, substitute the y's. So we see that 10 is one of the outputs, so I'm going to put 10 for y. Okay. 10 equals 5x. And then if I solve for x, divide by 5, divide by 5, x equals 10 divided by 5, which is 2. Okay, so that would be the first method. And we could plug in 15 for y, 20 for y, 25 for y. That would work. The second method is a little bit more general, but I think it can save you time. So inverse operations. If we are multiplying the input by 5, okay, times 5, what is the inverse of multiplying by 5? Well, the inverse of multiplying by 5 would be dividing by 5. And that's really what we did here, right? When I substituted 10 for y, we ended up dividing by 5 anyways. So this second method, inverse operations, once you figure out what you should do, you simply apply that to the outputs. Okay, so the inverse of multiplying by 5 is dividing by 5. So 15 divided by 5. 20 divided by 5. 25 divided by 5. Okay? So there you go. You could actually just substitute 15 in, 20 in, 25 in, but inverse operations is a little bit faster because once you figure out what operation you need to do, you can kind of skip the substituting in step, right? You just immediately do 15 divided by 5, 20 divided by 5, 25 divided by 5. So in this case, we were given the outputs and the rule, and we figured out the inputs. All right, let's do another problem like this. How about they give us this, y equals x plus 7, and then they give us, here's our inputs, here's our outputs. Once again, they're going to give us the outputs. Okay, we have 12, we have 21, we have 38, and we have 104. Okay. So like I said, we can substitute the y's in. That would be just fine. But a faster way would be, what's the inverse of adding 7? The inverse would be subtracting 7. Okay, so to find our inputs, let's subtract all of these by 7. So 12 minus 7, that would be 5. 21 minus 7, 14. 38 minus 7 is 31. And 104 minus 7 would be 97. So there you go. With function rules, we can take an input to produce an output, right? And then the operation part, that's the rule, right? Take an input, do something according to the rule, produce an output. And sometimes we can figure out the third part if we have the two other parts, right? If you had an input and a rule, you could find the output. If you had an input and output, you could find the rule by making a hypothesis. And then if you were given an output and a rule, you simply do the inverse of the rule to get your inputs. So if you have two of the three parts of a function, you are okay.